Welcome to Cisco HyperFlex video series. This is Distributed File System. The common data platform of a HyperFlex system relies on a distributed log-structured file system called StoreFS. It allows the system to distribute information across individual nodes and provides inline data protection and resiliency. When installing Cisco HyperFlex, you can either choose to deploy a normal HyperFlex installation with a replication factor of 2 or 3, which means that 2 or 3 instances of information will always be available in the HyperFlex cluster, which affects the amounts of failures the HyperFlex system can sustain before going offline. This choice is tightly tied to the StoreFS operation. To truly understand how the StoreFS works, you must keep in mind that Cisco HyperFlex relies on high-performance networking and in all but edge deployments comes with fabric interconnects as a part of the solution. The network is the relay between the servers and moves the information. But in order for the information to be written and then read, StoreFS uses different storage tiers of the HyperFlex solution. The caching tier is especially important when distributing the data. The data is cached on the caching drive in several ways to facilitate the file system operation. In all flash systems, cache drive is not used for read caching, since there is very little difference between the reading speeds of high-tier SSDs, such as the caching drive, and the regular tier SSDs, such as SSD capacity drives. This is why reading is done directly from the capacity drives. Write caching works in the same way on all flash as well as hybrid HyperFlex. The caching drive is used to cache all the writes as they get distributed. The write cache is split between the active and the passive cache. The active cache is the one that is currently being used to cache the data. The passive cache is the cache that is used when moving data from the caching drive to the capacity drives. This process is called destaging. The write cache is further segmented into several cache levels. The number of cache levels is determined by the replication factor, which you define on installation. In RF2, the cache is segmented into 2 levels, in RF3, in 3. Primary, secondary, and tertiary. In hybrid systems, the caching drive is also used for read caching. The write cache is separated in the same way as in the all-flash HyperFlex, but most of the cache drive is reserved for the read log. In a default hybrid deployment, the read log is used for most frequently used information as well as the most recently used information. This is the so-called write-through operation. When information is read from the capacity drives, that information is also copied to the read log, as it is forwarded to the VM. The information that is often used is also retained in the read log as the most frequently used information. There is also an option you can choose during installation which is intended for VDI deployments, and only caches most frequently used information. This is the write-back operation and does not cache the most recently used information. It instead only caches the most frequently used information to optimize VDI performance. While reading process is different in all flash and hybrid, writing process is the same for both solutions. Here we have an example of 4 converged nodes with replication factor of 3, indicated by 3 write cache tiers, and a VM which runs on the 4th node. The VM in vSphere is a VMDK file, and this VMDK is written to the shared data store. In the VM, an application is running, which requests the data to be written to the data store. Here's what happens. The data store is an NFS share and is mounted on all nodes. As the app requests the write to storage, the operating system running in the VM requests the write from the hypervisor, and the hypervisor starts a write to the NFS share. But this action is intercepted by the IO visor, which is a plugin in the hypervisor, and this IO visor chooses a CVM on one of the nodes to be the primary CVM for the written information. The local I/O visor forwards the chunk to the chosen primary node. Here, this is node 3. Once the chunk arrives, the CVM on the destination node compresses the chunk and writes the chunk to the primary cache, then chooses 2 additional nodes to act as the secondary and tertiary nodes, and again forwards the chunk to the chosen nodes. The now compressed data is written to the secondary cache on the secondary node and the tertiary cache on the tertiary node. Once the data is cached on the number of nodes defined by the replication factor, in our case this is 3, the acknowledge is sent back to the VMOS that the write was successful. This entire process of choosing the primary node, compressing, and duplicate caching is done for every chunk individually, choosing different nodes with no preference for the local node. Now we have 3 copies of the data chunks across the cluster, but that information is in the cache, not on the capacity storage. To move the cached information to the capacity, the D-stage process must be executed. A D-stage is initiated when the primary cache is full. Only the primary cache can trigger the D-stage, and the data in the primary cache is again distributed to additional nodes, since the secondary and tertiary copies of information are forgotten as soon as they are not necessary anymore. The initial write caching was done only to ensure we lose no data if a failure occurs, and is not reused. The primary cache is now full, and is write-locked. The contents of the primary cache are again cached twice on 2 nodes, and the caches holding the copies write-lock as well. But this time all the information is written to the capacity tier on all nodes. When the information is written to the capacity tier, the written information remains tagged as primary, secondary, and tertiary. This is important since the all-flash HyperFlex only reads from the primary copy. Flash drives are fast enough not to affect performance. Since spinning drives have much slower seek times, in hybrid HyperFlex all the instances of information are used to read from the data platform. When a read is initiated, the information is searched throughout the system. It is retrieved from where it can be acquired the fastest. First, the memory, then write or read cache, and finally from the capacity drives. This distributed reading and writing system distributes the load and storage capacity throughout the HyperFlex cluster, and it also provides resiliency to the cluster by distributing data in such a way that there is never a single point of failure. If a failure does happen, your data is safe, and the system performance is minimally affected across the entire infrastructure of the Cisco HyperFlex data platform. This was Distributed File System. Thank you for watching.